Hey nanotechnology folks, this is Dr. Habib Ahmad. I work at the Center for Advanced Electronics and Photovoltaic Engineering at International Islamic University, Islamabad. Today I'm going to demonstrate how to operate the plasma enhanced chemical vapor deposition system from CAEPE 1200. Now, let me tell you a little bit background about plasma enhanced chemical vapor deposition. So plasma enhanced chemical vapor deposition, for which the short form is PECVD, is a variation of chemical vapor deposition. Now we all know that chemical vapor deposition is performed at really high temperatures. Temperatures above 1000 degrees C, 1100, 1200 degrees C. Why? Because we have to activate the precursor gases. The advantage of using plasma enhanced chemical vapor deposition is that we can perform similar growths at lower temperatures in the range of 100 to 500 degrees C. How is that possible? It's possible because in plasma enhanced chemical vapor deposition we have high power radio frequency plasma, where in this system it works at a frequency of 13.56 megahertz. So with this high power plasma we can activate the precursor gases, and then deposition of the films occur inside this deposition chamber. So using PECVD we can grow the same films in the temperature range of 100 to 500 degrees C at lower temperatures. Now what is plasma? So plasma is the fourth state of matter. We know about solid, liquids and gases, but plasma is the fourth state of matter. Have you seen a plasma? So actually in fluorescent light bulbs we do have plasma. What is the plasma once again? Plasma is a combination of neutral atoms and molecules, electrons and ions, and those species inside the plasma react at the surface of our substrate in order to deposit films. Now let me tell you about the significance of plasma enhanced chemical vapor deposition system. Well, you know that silicon dioxide and silicon nitride, they are part of almost any kind of semiconductor devices and very large scale integrated circuits in the modern nanotechnology chips. So mainly silicon dioxide and silicon nitride kind of films, they are mainly grown using plasma enhanced chemical vapor deposition. Similarly with this tool we also grow silicon carbide and graphene film. Graphene, you know, is stronger than steel and it's lighter than aluminum. So really high significance films can be deposited using this plasma enhanced chemical vapor deposition tool. Now let me introduce you to this CAEPE 1200 plasma enhanced chemical vapor deposition system. This system actually is a modular system, which means that we have assembled different components in order to pack it into a single unit. So if you focus over here, we have got the chiller for the system over here. Similarly, over here we have the vacuum pumping system. We have the mechanical pump and we have the diffusion pump in this vacuum pumping system. Similarly, over here we have got the tube furnace and the heating chamber. Over here we have the plasma controller. Similarly, over here we have the plasma generator. Similarly, over here we have the gas mixing systems and a lot of knobs and valves in order to control the flow of gases. Similarly, over here on this side we have different cylinders connected to this chamber. So currently we have oxygen, nitrogen, argon, methane, and we also work on silane in order to grow silicon carbide films. So using these kind of films, these kind of precursor gases, we actually introduce them into this chamber through the mass flow controllers in order to grow nanotechnology films on top of different kind of substrates. Let me also show you what's there inside the tube furnace. So I open this tube furnace. Inside the tube furnace you see these different kind of filaments. These are actually the heating filaments. Now let me tell you about the ratings of this system. So it's a KGR 1200 system, which means that it operates in the temperature range of room temperature to 1200 degrees C, and that's a pretty high temperature. Like, we don't need to go that high. We generally operate this system up to 500 degrees C for various kind of applications, but still this system has the capability to even go up to 1200 degrees C. Similarly, we can also see this part of the chamber where we have these radio frequency filaments. So, and then you see the tube furnace running from this end to that far end, and actually I assembled this entire system myself, and the alignment was really crucial because you see this tubes, which is made up of quartz, has to go through the plasma generator and then through the heating system, and then we have to connect it to the mechanical pump and the diffusion pump. So the alignment was really crucial. Now, as I already told you, that this is a modular system where we have individual components and we put them together, but there are other variants of plasma enhanced chemical vapor deposition. You would see them like in a single cylindrical kind of package. Before running the tool, let me close this heating chamber now. It's kind of heavy, so you got to be careful. Similarly, let me close this plasma generating chamber as well. Okay, so these two are closed now. Before running the system, we need to make sure that different valves of this system are closed. So first of all, we need to make sure that everything is turned off at this point. The chiller is turned off, mechanical pump, diffusion pump, the plasma controller, the heating chamber, the mass flow controllers, everything is turned off. Also, we need to make sure that the valves connected to this system are closed. So for example, this valve over here, which is for the precursor gases. Similarly, if you come over here, this valve, which is connected to the output of the tube. Similarly, this butterfly valve, which is connected to the mechanical pump, and then this butterfly valve, which is connected to the diffusion pump. We need to make sure at this point that everything is closed. And then at this point, I'm going to tell you how to run each component of this system one by one. So the first thing we are going to switch on is the chiller part of this plasma enhanced chemical vapor deposition. Before turning on the chiller, we need to make sure that this outlet part is connected to the top of this vacuum pumping system. Similarly, this inlet part should be connected to the bottom over here. And also we need to make sure that the deionized water level inside this chiller is inside the green zone. So now we come over here and switch on the chiller. As you can see, the chiller is running now. It's the month of July and the temperature is pretty high, around 30 degrees C. But the chiller is going to start circulating the DI water, and it's going to cool it down with the passage of time as well. So the temperature of the system is going to decrease with the passage of time. Now we turn on each and every component of this plasma enhanced chemical vapor deposition system. So we switch on the main switch, and then we switch on the heating chamber. Similarly, we turn on the plasma controller. Similarly, we turn on the mass flow controllers, and this part at this point is crucial, where we have the vacuum pumping system. So before turning on the vacuum pumping system, we need to make sure that these butterfly valves are closed. Similarly, this valve over here should also be closed. So since these butterfly valves are closed and this valve is also closed, so at this point we can switch on the vacuum gauge, and after that we switch on the mechanical pump, and it's going to start pumping down the chamber. So at this point we need to make sure that the mechanical pump is running, and also at this point we can slowly open the butterfly valve for the mechanical pump, and also keep an eye on this gauge, making sure that the pressure of this gauge is going down. So as you can see, the pressure of this gauge is going down. Keep opening the butterfly valve for the mechanical pump. Okay, now we have fully opened the butterfly valve for the mechanical pump. At this point, we have to wait until the pressure gauge shows 1 into 10 to the power of minus 1 megapascal. Now that the mechanical pump has pumped down the chamber to a reasonable pressure, so at this point we can turn on the diffusion pump as well. Just to let you know that this butterfly valve for the mechanical pump is still open, and this butterfly valve for the diffusion pump should be closed at this point. So we switch on the diffusion pump, and we wait for 60 minutes. So I will talk to you after 60 minutes. So it's been 1 hour. So now what we are going to do is, the mechanical pump is on and its valve is open. Similarly, the diffusion pump has been on for 1 hour, but the butterfly valve for the diffusion pump is closed. So at this point we are going to close the butterfly valve for the mechanical pump, and slowly, very slowly, we are going to open the valve for the diffusion pump, and keep an eye on the pressure. So as you can see, the pressure is going down. So at this point we are going to perform the settings of the heating chamber. So I want to perform the growth, for example, at a temperature of 150 degrees C. The way we set it up, we click on this button, AM. It takes us to the temperature setting. The initial temperature, I have set it to 0, but you can set it to like room temperature, which is going to be 25 degrees C. After that, I want this temperature to ramp up to 150 degrees C in 20 minutes. So this is the time setting. Here is my dwell temperature, or you can say the growth temperature. You can further increase the temperature by clicking on this up arrow, or you can bring it down by clicking on this down arrow. 150 degrees C works for me, so I'm gonna go with this setting, and I want it to stay at this temperature for 30 minutes, which is also called the dwell time. So 30 is fine for me, but you can further increase or decrease this value as well. Here is the end point of the dwell time, 150 degrees C of the dwell temperature. And finally, if you want to close the program at this point, so you just set it at -121. However, you have the chance to include more number of steps into this program as well, which we don't need, so we are going to close it at after the third step. And wait for a minute, and it's going to take us to the measured temperature now. Also, we click on this turn on button at this point, and then we press this run button for a few seconds. It's going to start running the program. Now you see this command run. So the heating chamber has started running, and it's going to ramp up the temperature to 150 degrees C in 20 minutes. Okay, so now we are going to introduce the flow of the gases into the chamber. So we have got a gas tank over here, and we are going to open the valve of the cylinder. Now this line is connected over here to mass flow controller number 3, which is for argon over here in this case. Today we are not growing any actual film. The goal is quality assurance of this tool, because we moved this tool from another building to this building. So we want to double check the operation of each and every component of the plasma enhanced chemical vapor deposition. Now over here we are going to set the flow of the gases. So here is the output valve, and here is the valve for mass flow controller 3. From this knob we can open the gas flow, and here is how we control the flow rate of the gas. We are going to increase the gas flow to 35 SCCM. Almost there. Okay, so the flow rate is set. Now we open the output valve, and also here from the gas flow controller we have this output line which is connected to the input of the tube furnace, and then we got another control valve over here. So now we are going to open that valve so that we allow the gas to flow into the tube furnace. And this is going to increase the pressure inside the chamber. We are going to let the pressure stabilize, and after that we will turn on the plasma. Now that the flow rate is set, we are going to set the plasma power. So here is the knob to increase. Over here you can see that we are increasing the plasma power. So right now it's at 4 watt, 6 watt, 8 watt, 10. We want to take it up to 50 watts. So I'm ramping it up further and further, as you can see. Okay, and now in order to turn on the plasma, I'm going to press on the on button. As soon as I press on the on button, you can see over there that the plasma would turn on. So now here is the plasma. The plasma is created, as you can see over there. Now at this point I press the off button over here, and it turns off the plasma. Now that the plasma power is off, we close the flow to the chamber starting from the gas cylinder. why do we start from the cylinder? We want to cut the supply from here. Now there are still some gases in the pipeline, and we want our pumping system to pump out all the gases in the line. We don't want to leave any pressure that might damage our mass flow controller. So you close all the valves to the chamber. After closing the gas supply to the chamber, we can just turn off this unit now. Also, we don't need the plasma power at this point, so we are going to turn it off as well. This temperature unit is naturally cooling down, so we would allow this to stay on unless we arrive at room temperature, and after that we are going to shut down the heating unit as well. And after we shut down the heating unit, what we are going to do is we are going to close the diffusion pump valve, and we are going to shut down the diffusion pump. And after that we are going to let the mechanical pump run for around 1 hour, and after 1 hour we are going to shut down the mechanical pump as well. And that would complete the experiment for the plasma enhanced chemical vapor deposition. I hope this session was useful for you. Take care. Until next time, adios.